Hi guys, this video is aimed at showing you how to use vos-viewer to create a map of your research field. So the way I did this for the chalcogenides research map, which was 3 or 4 years ago now, was use the Web of Science. So first of all, we need to get data. So in my case, I would type something like chalcogenide as a topic, and then just do a search. You see the 20,000 results if you type chalcogenide into the Web of Science. So then we have to export all of this data. You can probably order it or filter it a little bit more if you wanted to. For example, only look at articles. So now there's 16,000 articles, so I can refine that. And just to make it faster, no, I'll leave it like this. Okay, so there's 16,000 articles. So then we need to export the data. If I remember correctly, we can do that somewhere. Just here, export. And how did I do it? Maybe I exported it as other file formats. Yeah, this is the problem. You can only export up to 500 records, and there's 16,000 here. So we're going to have to split this into 32 downloads, which is slightly annoying. But so we can export it. I would export it as a plain text file. The first 500 records. Export. So it should have done it. It's probably in my downloads folder. So it's generated 500 records here. So next I'll download the next 500. This is the manual bit. Maybe you could make some macro or something to do this more easily, but this is the kind of annoying bits. So we'll go to 501 to 1001, 1000, sorry, and then export again. Now those two files should be different. So this was the first one. Wang was the first author in the first one, and the second one is someone else, Wygant. Okay, so I'll just do this a few times. I'm not going to do it 32 times because this is just a demo, but if I wanted to get all of the data, I'd do it 32 times. Make sure that you've got the abstract in there. So 1001 to 1500. $1,501 to 2000. You need quite a bit of data to do this. 2,501, 2,500 to 2,501 to 3,000, right? Okay, I wasn't paying attention whether I did this correctly in terms of the order of the numbers, but I've got 1, 2, 3, 4, 5 files. Now I just needed to put them into one big file. So to do this, I just used grep, not grep, cat. So the file should be there, ls. So you can see these are the 5 files that I have just downloaded. Maybe I'll make this a bit bigger so you can see it on the screen. So I'll just call this chalk. Actually, so I'll use the cat function, the concatenate function. Then I'll transfer all of this data into a single file. Saved rex.text to thg, as in chalcogenide data. Oh no, just ch. I'll just make it quick. Text. And then I'm using the double greater than symbol, which will not overwrite each time I do this afterwards. Then 1. Oh, it doesn't like this. I wonder if this will work. No, that's not going to work, is it? I have to use an escape character, I think. So spaces and not generally liked, and also these brackets not generally liked in Linux. So you have to use escape characters. And there are 4 records. So this is the new file is here. You can see it's 4 megabytes. So that's correct because each of these are around 800 megabytes and there are 5 of them. So that's all of the data. Then you need to open up vos-viewer. So I already downloaded this. It's just a free app you can download from the internet. This is probably an older version because I did this quite a while ago. Okay, and then you can create a map based on network data, create a map based on bibliographic data, create a map based on text. We're not. I don't think we want the bibliographic data. I think we want to use the text data. I think this is not going to work actually. Yeah, this is not going to work. I need to edit this file because this file, I just want the text, the abstracts. I don't want anything else. If I have a look at this data, chg.text, we've got all the authors and all the other things, but I'm only interested in the abstract. So the abstract always starts with this AB and ends at OI. Is it all one? I wonder if this is all one line. I think it is. So this is all one line, so I can just use grep to grep for AB, I think. Let's just try that. Grep. I'll just is it like this? Saved. Yeah, so you can see now I've only got abstracts, I think, and there's sort of other lines that happen to have AB in it. So this has just created one file with just abstracts. So now I'm going to do that on not the saved rex file, but the chg.text file, and I will send it to another file called chg2.txt. So now I've just got the abstracts without any of the other junk. So now let's try and do it again. So create a map based on text data, read data from bibliographic data, read data from file manager. Maybe I can do the original way. Let's just try and open the original data first. Hmm. Okay, it seems that if I read in the saved directs file, then it will work. Fields which terms to be extracted, abstract. Is the only one I'm interested in. Ignore abstract labels, no copyright statements. It's fine. So there's several counting methods you can use. Full counting means if the same word appears many times in the abstract, then it will count it that number of times it appears. Binary counting means it'll either count it one or it'll only give it count it once in the abstract. You can also add a thesaurus file. If I remember correctly, this will remove things like words which you are common, which actually have no meaning really, like maybe and or the. But I think those are not the those ones are automatically done. But there are a few others you can add them yourself. So it's minimum number of occurrences of a term, so it's only going to plot things which have occurred 10 times or more. You can change these numbers and see how it looks. A relevant score will be calculated. Based on the score, most relevant terms will be selected. Okay, let's leave that. So these are the some of the words that it's picked out and the number of occurrences. Can we sort it? See how you should go through this and see which words have got absolutely nothing to do with the research. You can see that most of them are okay, but way, approach is probably ability is not useful. These ones can be removed. And I just remembered what the thesaurus is. The thesaurus is on the previous page is a text document that will say whether two terms are similar. For instance, PCM and phase change material are the same thing. So we need to make a thesaurus file to tell the computer that not to distinguish those two. I'm not going to do it now, but you can try it. And just get rid of words which are kind of not useful, like example. Just go through and do this. Then the network's created. Then there are various ways that you can visualize this. So I can't remember exactly how to do this, but you can change the strength of the lines. Say like a minimum line strength. Just replotting it now. It's kind of frozen whilst it's doing it. But you can already see that there are certain fields that emerge from this, like thin films, very common in chalcogenides. Optical properties are very important, like semiconductor and band gap properties are important. Then there's more like thermal properties and the electrical properties, and you can see how all of these things are linked to other areas. So yeah, there are ways as well to change the way that this is all presented. It's just ways of that it will represent the re-represent the data. So if I change the traction to something higher or lower, I think it will become. If I make it lower, I think it will be more spread out. Maybe I make the repulsion higher. and start to change the way the map looks by playing with these layout functions. The best thing is just to have a play with this. Minimum cluster size. That's the bigger. Best is just to play with this and experiment and try to make it look presentable in a review paper. Anyway, I only did this with a small number of terms, so let me try again with the other one. I'm not sure why the other file didn't work. vos-viewer. I've got to go to a meeting in a minute. So create bibliographic data from Web of Science. And last time I chose last time I did this one, and this one didn't work, right? Doesn't like it for some reason. Let me just have a look at the file. Yes. I think it might not like some strange formatting at the beginning. Is that right? Open it in a different application. It's a text editor. It looks okay here. Let's try one other thing. I'm just going to edit the text file a little bit. It might not like it because I have a strange header and some of the so if we have a look at this, we have I'm not sure what these are. We have the, I can open it in something that's easier to see. Every time we have a new article, we have a space, and then we have some PT, whatever that means, and then the file. So I'm just going to, so I think this could be the reason there's an error. There might also be something at the end of this. So we have EF at the end, but all the other files end in ER. So I'm just going to delete EF. Maybe this is the reason it wasn't loading. And I'm just going to delete this and leave a space, and then save it. And then I'll do the same for the other files. Okay, it'll be faster for me to do this in here. So I'll delete that line, insert one line, and then go to the end of the file, and then I'll delete this line. And that one. Just check the first one again. That one I've already deleted it. and at the very end. That's fine. And file number 3. So I'm going to delete this line, this line, this line, insert a space line, and then go to the very end of the file and delete that line and that line. And file 4. Probably make a script to do this if you have a lot of them to do. Should PTJ be there? PTJ should be there, so I shouldn't have deleted that line in the others. I'll put those back in if I did. So I left it there. And 1. The only one I haven't done is 5. Wasn't the 5. I've done 4, right? Yeah. I didn't leave a space. Should be a space. And at the end, it's okay. I've done 3. It's fine. The end is fine. I've done 2. And that's great. The end is fine. And just have to do the first one. The first one, we don't have to change the header. We just have to change the very end. It should be delete that EF. BB. And then let's combine all of these again. Oh no, first we'll have to make a new file, and I have to add the others to it. And if we look at the new files, text, okay, all the data's there. If we go to the very end of the file, this is the very end of the file. I have to tell it's the end, EF. So hopefully now it'll open. So CHG. It did, it opened. So I'm going to wait. Yeah, this is correct. This is correct. Type of analysis. Don't want to do this analysis. Create a map, not text data. Next. Read data from bibliographic databases. Next. Then choose the file, CHG. Okay, and then next, we're just going to look in the abstract field. So ignore structured abstract labels, yes, and ignore copyright statements. Now it's going to take a lot longer because I've got 5 files that it's got to read in. Oh, it's only reading in 1 file, but I compressed 5 files into it. So we'll do binary counting as well. It's good if you have a thesaurus, which will common words which appear multiple times in different forms, like PCM and phase change material. You can tell vos-viewer to treat them as the same word, so it doesn't count them in 2 different groups. But I didn't make a file for this. It's just a text file, if I remember right, a list, maybe tab or comma separated, with the name and then its other name. Okay, we'll just keep the minimum number of curves 10, and we'll keep this the same. That's creating relevant scores. Okay, we'll leave this in and finish. So this is what the research field looks like. This is kind of cool. I can even see superlattices and van. I assume that's going to be superlattice van der Waals, which is kind of nice. And then you can also do other types of, present this in other ways as well. So this shows how the research field is evolving in the last few years, from 2018 to 2019. You can see certain things are not as active anymore. Kind of looks like thermal kind of characterization properties are not as active, and you can see that certain other fields are becoming more active. Stuff to do with, what is this? Kind of electrical properties. And then what's this density visualization? You can see where which topics are kind of interesting, or lots of people are publishing in. You can also, I didn't do it here, maybe I've got quick time to quickly play with this. I'll try one more time. I might do it on a smaller, okay, I'll do it on a big scale. So I'll just run vos-viewer again. You can also analyze who collaborates with who, which is kind of informative to see who the clusters or cliques in the fields. So let's see if we can do this very quickly before my next meeting. You choose bibliographic database, and then you choose Web of Science. Then you read in the file, so chg.text. Next, run file name. That's in the downloads folder. chg.text. So you can see co-authorship, see who's publishing with others. See all the authors now. So there you go, you can see who the big guys are in the field and who they work with. So if I think we can zoom in on this. There's a zoom button, there's a zoom scale maybe. Zoom in. You can see in China there's a huge group of people that like to kind of work with one another and cite one another, which is interesting. I know that some labs, they tend to have like little cliques where they deliberately cite one another to bring up uh, their impact factors. I'm sure that's not the case here, but you can kind of see all the cliques in the fields. The biggest one is in China, it seems, for the chalcogenide field. Although JJ is from MIT, but it seems that he's connected somehow to. Okay, well, it's kind of interesting. So he goes through maybe these are a set of MIT guys, and then it kind of goes outwards like this. You can see who's kind of publishing when, so who the emerging people are. So the biggest clique is this clique in the middle. Interesting. Anyway, that's it. Yeah, I have to go to my meeting. You can play with this. If you have any questions, let me know.